So good afternoon, everybody. I'm Lucian. I'm working with RTE, so the French transmission system operator. I'm working as the R&D program director, and my main responsibility is leading the open source strategy and open source office of RTE. So we talk about open source, so not directly or specifically about cybersecurity, but I hope that you will see some connections with the topic. So why are we talking about open source at RTE? About almost two years ago, RTE decided to undertake an ambitious shift towards open source for the digitalization of the grid. And underlying this decision, there is an urgency. The urgency is related to the climate change and the need to adapt to a completely different power system if we want to achieve the targets and meet the challenges of the climate change. And for instance, if you look at the last IPCC report that assessed the impact on various societal criteria of the climate change, if we, for instance, reach certain warming thresholds, what you can see is that even though we would meet the ambitious 1.5 degrees Celsius target, a lot of criteria would go reddish. That also means for us that the pressure from the society, from the political environment to cope with this big issue will go rising in the future. So for sure, RTE as a company does not want to be a blocking factor on this path. So we have to prepare to a completely different system, and we have to prepare very fast because we have more or less 10 years in front of us, which is a really short period of time. And RTE, but we are not the only ones. Many grid operators decided to rely on more digitalization to transform and to adapt to this new context. And then we come to this tricky equation that we would like to solve. So there is a common adage in the software world that says that if you want good software, if you want it fast, or if you want it cheap, you can pick any two of those three properties. Unfortunately, in our context, we cannot choose. We need the three. Why that? First of all, because we have to prepare to a system. You all know about this, but we have to prepare to a system that will be much more decentralized, that will have more variability in the generation patterns, for instance. So we will need more complex software to manage this increased complexity. Then we will need this software much faster than we were used to. Why that? Because the pace of development of those new technologies, such as PV generation, wind generation, it's much faster than what we used to with big thermal power plants. We also need to adapt to new uses that could come very fast. For instance, electric mobility can expand rapidly. So we need software faster. And then cheaper, why that? Well, in the end, the bill for the end consumer will be important, and we will not be able to increase it. And so we have, unfortunately for us, we have to deal with that with a constrained budget. So then looking at this equation, we realized, and now we believe, that open source can be a lever to solve it. Why is that? So what is open source about? When one thinks about open source, one usually thinks about a license. So a license that has been promoted by Richard Stallman, who is, you can see his face here. And his aim was to promote freedom on the cyberspace. That was the initial aim of open source. But when you look at who's doing open source today, you have the big contributors are Microsoft, Google, IBM, Red Hat, all those big IT companies. And for sure, their main motivation is maybe not the initial motivation of Richard Stallman. In fact, those companies realized that open source can be an outstanding collaboration framework to build software collaborating across organizations. So I borrowed this slide from the Linux Foundation, and they make an analogy between open source and making sandwiches. So when you look at a sandwich, most of the volume is bread, and bread is the same from one sandwich to the other. And then what is really differentiating is a secret sauce that you put in the middle of the two slices of bread. And it's a bit the same when you have to build a software solution. Most of the code will be code common to other uses, to other software. And this is what we call common plumbing. And that's the majority of the code. And then what is really differentiating in the software may be a minor part of the code to be developed. So if you can share the cost of developing the common plumbing with others, that means that you would be able to focus your competence, your resources on the differentiating and strategic part of it. So what do we expect from this? First of all, a leveraged development model. That means that instead of building the common plumbing alone, we would share the cost with others that share the same needs. And then with a constrained budget, that would mean that we would have more money to put into innovative functions. So that's the most obvious benefit of open source, but that's not all. Looking at the experience of other industries, like the telecom industry, internet industry, automotive industry, etc., those guys told us that they also noticed that with open source collaboration, they managed to achieve also better modularity, better interoperability, and shorter release time cycles. And that is also interesting for us because we have to adapt incrementally to different contexts. We don't know exactly what kind of solution we will need in 10 years from now. And we want to move step by step. The third benefit, not the least, is that open source framework can also foster innovation. Academics like this kind of collaboration framework because they allow them to build on their previous works, even when the partnership with the industrial stops. So until now, what I said is a bit theoretical, but more than 1 year ago, we had the opportunity to visit all the open source initiatives from other industries, and especially the telecom industry. And they explained us what they did, what AT&T in the US did to face the 5G, the challenge of the 5G, the development of 5G. And to adapt their grid, their telecom network, to a huge increase of telecommunication needs, they decided to rely on the virtualization of networking equipment. And when they decided to undertake that strategy, their vendor partners did not follow them at this time. So then they decided to do it themselves, but they realized that China Mobile had the same strategy. So then they partnered together and they launched an open source project called ONAP. And that was in 2016. And today, or when we met them 1 year ago, they already announced that they were joined by Orange, Verizon, Vodafone. So 70% of the market of the telecom sector. So that's a great illustration of how open source can be an accelerator to meet challenges that are pushing us to a new context. So then, a bit than early 2018, we entered into contact with the Linux Foundation, and this led us to create LF Energy. So LF Energy is an open source foundation dedicated to the energy sector. We launched that because on our side, when we decided to go open source, we realized that it's not just putting code on internet, that we needed a governance framework that could be attractive for partners to join us. So LF Energy has been launched by a first round of partners. I'm happy to show you that the community is expanding. So for instance, a couple of weeks ago, Alliander, the Dutch DSO, joined the initiative. So now we are working with Alliander, and that's really interesting also because we are a TSO, they are a DSO, and the TSO-DSO interface is something that will need to be improved in the future if we want to adapt to the new system. So what are we doing at LF Energy? So LF Energy is an umbrella foundation, and it hosts various projects. So recently we drafted a really high-level architecture to illustrate what is the scope of LF Energy. So we draw some kind of big boxes that cover several topics from customer and market solutions to system management solutions, asset management solution, acquisition and control, and some kind of common IT. And then we put the existing LF Energy projects on this map. All those projects do not cover every function in each category, but it's just a way to show that we are targeting the various functional blocks that we need. And we want even to more details. So I will not spend 5 minutes on each topic now, for sure. I will not comment this, but what I want to show with this is that this big architecture can also help us to see what needs to be built. And then it is not, the message is not that every single line of code that will fulfill all those functions will be open source. That's not the aim. What we want to achieve with open source is everything that is needed to ensure a common plumbing and an interoperable framework. But then on top of this framework, we can imagine that proprietary software and legacy software and open source software will live together. So to achieve this big picture, we will have to face several challenges. One of them will be ensuring the interoperability of all the functions, and this beyond the boundaries of one organization. So I talked about the TSO-DSO interface. This is one key interface that we will need to cross. Then, for sure, there will be no monolithic solution that can answer the global picture. So we'll have to go to more modularity. We will need to share and pool components as much as possible to save costs, to be more efficient, and to go faster. And also, we have to think this is not, we cannot draw today the target picture, because the system is changing, and I cannot tell what kind of solutions I will need in 10 years from now. That means that we will have to learn by doing and build all this incrementally with the shorter release time cycles. In addition, we are inspired by some innovation concepts that come from the internet and telecom sector. And those people have adopted this kind of innovation pipeline. So first of all, virtualizing functions. Today, we buy a lot of functions in terms of physical devices. And we will need, if we want to gain agility, we will need to transfer those functions into software. Once we have this virtualization, then we will need to disaggregate those functions as much as possible to have smaller modules that on top of which we can build automation, then package all this into microservices and build the various solutions and platforms to fulfill the business needs that I mentioned previously on my slide. So as a conclusion, first of all, until now, I haven't mentioned cybersecurity at all. So that's because I want to leave it for the panel discussion. And for sure, open source and cybersecurity is a topic that comes quite often to the table. So we will address it during the panel discussion. Thank you.